Hello, we're going to present a low-cost, low-technology, small-size and easy-to-manufacturing ventilator. Let's first see this ventilator's parts. Some wooden plates, bearing some bolts and nuts, 12 volts gear DC motor, 2 cable ties, the rotor and knob, the presser, the pendulum, the slider, the resuscitator, PWM circuit, 12-volt DC power adapter. And now, let's show how it works. As we can see, a reciprocating presser is moving linearly forward toward a resuscitator, which ends in squeezing it and then backward to release it and let it restore its original shape and be refilled with air to be ready for the next cycle, that considered as breath cycle. The reciprocating presser is derived by a rotor which rotates with the aid of a DC motor. The rotor and the reciprocating presser are linked through the popular in mechanics quick return mechanism with its mechanical parameters and its main role, which is to convert the rotational motion provided by a rotating element to a reciprocating linear motion presented in a reciprocating element that moves with two different velocities. As we can see, although the rotor has a constant rotational speed, the reciprocator moves slower in the forward stroke than it moves in the backward stroke. That's because it takes about 2/3 of the full rotation of the rotor in the forward stroke and only about 1/3 in the backward stroke, which makes it takes longer time to go forward than going backward. This can help us provide a moderate inhalation pressure to the patient, as the resuscitator wouldn't be squeezed rapidly. Moreover, it leaves more time for the resuscitator to be filled again with air to be ready for the next cycle. One of the advantages of using this mechanism to derive this model of ventilators is that it's possible to control the length of the stroke in which the reciprocating presser moves forward and backward, which makes it possible to control how far can the presser press against the resuscitator. This in turn can make it possible to control the tidal volume, which is the volume of air to be forced into the patient's lungs. The more the reciprocating presser moves towards the resuscitator, the more the resuscitator squeezed, and then the more the tidal volume can be provided. This can be simply done by changing the position of the shown pin. The more it's placed farther from the center of the rotor, the more the tidal volume can be provided by the ventilator, and vice versa. In addition, the rate of the breathing cycles provided by this ventilator can be easily controlled by just rotating the potentiometer shown. This potentiometer is a part of a designed electronic circuit that controls the ventilator's DC motor speed. Hence, by changing the DC motor's speed as shown, the rate of breathing cycles can also be changed due to the different number of strokes done by the reciprocating presser in a specific time interval. Although the usual operating breath rate range in between about 12 to 20 breath cycles per minute, this ventilator is capable of operating until 30 breath cycles per minute. One more optional benefit of this ventilator, if the budget suffices, is that it can be powered by a 12-volt DC battery in case of unavailability of power source. Finally, this video illustrates how easy can this model be built.